Hey there, everyone. We'll go ahead and let people start filtering into the Zoom room. Thank you so much for joining us today. We are so excited to talk about the superpowers of Graphical Analysis Pro with you today. While we're kind of letting people get adjusted, settle in, why don't you go ahead and head to your Zoom window and click the little chat box at the bottom there. I would love to hear from you and just find out if you've joined us for a webinar before. So you should be able to pop in the chat there a little message to everyone and just say, heck yes, I've been here before, or no, this is my first time. It's a great way to kind of start chatting with one another. Very cool. It looks like it's a few folks first time attending one of our webinars, and we've got some returning folks. Good to see you, Jack. Awesome. It is so great to hear that you all are loving our webinars. We have another awesome webinar kind of queued up for you today. We still have folks filtering in, but I do want to make sure I'm being respectful of your time. So I'm going to hop into my little spiel here, and then I'll pass you off to our fabulous presenters. Um, so basically, I just want to let you know that a recording of this webinar will be going live on our website as well as our YouTube page. That usually takes about 3 to 5 business days to go up. But as soon as that recording is live, I will send an email of that to you. So just keep an eye on your inbox and I'll get that sent your way as soon as possible. Myself and Jake will be watching the chat today, the same chat that you're popping answers into right now. So if you have any questions, feel free to pop a question in there. We'll try to answer as quickly as possible. But if there's something that we can't answer in the moment, we might stop Tom and ask your question or follow up with an email. So we look forward to hearing from you. And with that being said, I'll go ahead and pass you off to our fabulous presenters. Thank you all for being here.
Thanks, Dylan. I'm Tom Smith. Been with Vernier for almost 9 years now. It'll be 9 years on Friday, as a matter of fact. And before that, I taught physics and engineering at a local high school. Jake, do you want to introduce yourself?
Sure. My name is Jake Hopkins. I've been with Vernier over 25 years now. I'm one of the physics guys, and my standard joke is that I've been running the projector since I was in 7th grade, but the projectors just get fancier and fancier as the years go on. So I am still the geek running the projector. So I'll be answering questions on chat, and feel free to, if you have anything that you definitely want to see or questions ahead of time, go ahead and put them in there and I'll kind of queue them up. And Tom is the expert and he will provide all of the detailed answers.
Great, thanks, Jake. I'm going to start sharing my screen and we'll get this kicked off here in just a moment. And looks like I'm sharing the correct screen. Check me if I'm wrong with that, Jake, but you should be seeing this. We're going to talk about Graphical Analysis Pro features, specifically to how that can enhance your physics classroom. And the topics that I want to cover today are, see if I can bring this up. We're going to talk about data sharing over the internet, using embedded sample experiments that are part of the Graphical Analysis Pro, synchronizing your own experimental data with video, which is pretty cool. We'll take a look at some of the advanced curve fit options, and if there's time at the end, we'll demonstrate some FFTs. So Graphical Analysis Pro is a subscription to Graphical Analysis, the free version. You know, both of them are really capable data collection and analysis tools, and we're just going to kind of dive in and look at this. I will mention up front that, you know, Graphical Analysis is a 5-platform piece of software. It runs on Mac and Windows computers, as well as iOS and Android devices and Chromebooks. And the software pretty much looks the same regardless of which platform you're on. And again, we're going to be focused on the Pro version. I'm going to go ahead and make a couple of changes here. The first thing I always like to do is to increase the font size when I'm doing a demonstration like this. So I'll just bump that up a bit. And so you can see the labels a little bit easier here. And then since we're dealing with Graphical Analysis Pro, we really want you guys to play along with us if you can. A lot of what I'm going to be doing is sharing my data over the internet. So if you have graphical analysis on your computer or your device with you, I'm going to share a code that gives you access to Graphical Analysis Pro. It's a key that will last for about 2 weeks. So you're welcome to play around with it for the next couple of weeks. If you're already a Pro subscriber, great. We'll just show you some of the tools there. So I'm gonna, this would be similar to how you would distribute Graphical Analysis Pro to your students. So I'm just clicking on the 3 dots, other options icon there, come down here to distribute app, and you get this URL with a key embedded in it. I'm going to copy that link, and I'll just put that link in the chat so that you have access to it. So everybody should be able to capture that, that URL. And I'll show you what happens when you open that up, just to kind of demonstrate if you're not playing along, you can still see what's going to be exposed there. So this is what pops up if you enter that URL. It gives you a license key. Again, this is a short-term license key. It gives you the option of opening up graphical analysis in a browser. So this is, we have built a progressive web app that just runs in a Chrome browser, which is great. If you prefer, and what I'm going to be demonstrating is running this in the native application that's installed on my computer. And if you were to click on that, it would open up this where you could either download the appropriate version, or if you already have graphical analysis installed, it would just allow you to open it up and install that key on it. So with that, I'm back at graphical analysis, and I'm going to connect my first sensor. I'm also going to change which camera so you don't have to look at me. I have a camera set up here with a go direct force and acceleration sensor. I have a couple of springs here, just stretchy springs. And I'm going to set this up as if I'm running a demonstration in my classroom. So think about having this, maybe you're doing as part of your lecture, you're doing a demonstration, and you want your students to be a little bit more engaged in the activity rather than just passively watching, but to actually engage in the material. So there I've connected my force sensor. I'm only concerned about the force sensor, so I'll just use that particular sensor channel, and I'll click done to get into the graph. So now it's all set up, ready for me to collect some data. I know from running this previously that I want to change this. So I have 8 seconds of data collection just to give me enough time to reach over there and stretch that spring out. What I'm going to be doing is, I have this spring right here. I'm going to stretch it out 10 centimeters. So I have it kind of set at my 0 point on the ruler, and I'm going to slide that out 10 centimeters and just see how what that force is. So first thing I might do is just zero my sensor, get that set up for that particular orientation. And now I can hit collect and stretch this out until the spring gets to 10 centimeters. There we are right there. So I'll let that go. And so, this might be part of a discussion about Hooke's law or something like that. We can zoom to the data, talk about, okay, at 10 centimeters, this was the force I had to apply. And then I might challenge my students to think about, well, what's going to happen if I attach a second spring to my force sensor? What is that going to look like? And at this point, they're just passively watching. But in order to have them have the data in front of them, I'm going to start a data sharing session. Now I'm going to set this up, show you how to start a data sharing session. Then I'm going to turn it over to Jake, who's going to demonstrate what this looks like on the student side in this particular scenario. So I'll go ahead and start a session. This gives me this key here. First thing I'm going to do is I'm going to copy that into the chat. Oh. There's that key. And then I can also enlarge this so you can see EBB8HV. And with that, I'm going to stop sharing so that Jake can take over and show the other side of the story.
All right, so I will be the pretend student here. Now you can all try this. Feel free to follow along from home. So when I first open graphical analysis, I have this option, and usually I'm going to go in and collect data from sensors that I have connected. But in this case, if Tom is demoing to the class, I can grab that data remotely. Now I could be in the class or I could be at home if I'm a remote student. So I go into data sharing. And I have options here of online or local. We're using online. So I'd already copied the source ID that Tom put in chat. So I'm just going to paste that in here. So all I have to do is paste that in. And when I say connect, my copy of graphical analysis connects to his copy of graphical analysis, and I get the data. Now your students will be able to get data from you, the instructor, in the same way, but they won't be able to share their analysis, answers to the questions, etc. So a pretty common workflow is to get the data out to the students and then have them do all the critical thinking and analysis on their own. But it's a nice way to share if you have a complicated setup or anything like that. Easy to share the data out. So I think that's my only job, right, Tom, on the data sharing part.
Yeah, I think so. It looks like somebody wasn't able to get that data sharing code, so I'll throw that back in chat here in a second, just to make sure you have it.
Oh, I see. Your chat, Tom, went to just the host and panelists.
Oh.
So I'll put that out in the share to everyone thing. Zoom thinks we're trying to keep secrets, but we're usually not very good at that.
Not true. Yeah. Okay.
So I put that out there for everyone, and I stopped my share. So that's what a student would see. And now we'll go back to Tom for what the teacher can show.
There we go. And there's that code in case you missed it in chat. Sorry about that. So, and you can check, well, you're the person who is sharing their data. You can check and see how many people. Right now we have 11 clients connected. So you can see if your students are connected and more are connecting. That's great. So all of you should see this data. I can pose the question to you, well, what is this going to look like when I attach this second spring to my force sensor and stretch it out again 10 centimeters? And what you're able to do for if you're a student in the class is you can make a prediction. Now, having run this lab before, I can kind of anticipate that my prediction is going to be more than 1.5 newtons. So I might actually come in here to my graph options and edit those so that I can look at something closer to maybe 4 newtons for my top range of that y-axis. Just click outside of that. Now, all your students have that challenge. They're gonna draw a prediction, add a prediction here. So all of you can be doing this yourselves. You can add your own prediction. You'll notice that you don't see my prediction on your graph. You only see what you're doing on your graph. So you get the data, but as Jake said, none of the analysis or anything like that. Now, who knows if, I may be able to control the experiment, so this is right, but let's just go ahead and run the experiment, and we'll take a look at that prediction at the same time that we're collecting this second round of data. So I can hit collect. I can hold that down. And again, I want to go out to 10 centimeters. And I can see that it flatlined at the very top there. My prediction wasn't very good, but I can also have a discussion with my classmates to figure out, well, why does this make sense? And if I want to go back and take a look at that initial run of data, I have that data right there. It's all available to me as data that has just been shared over the internet. And as Jake mentioned, this can be at home. This can be a classroom experience like I'm describing here. It can also be just lab partners. So one person is collecting the data on their Chromebook, and they can set up a data sharing session to be able to share that data with their lab partners. So very useful, versatile tool. Also thought about this would be a great way to engage in some citizen science or sharing data from school to school. Occasionally when I was teaching, I would have an exchange student in my class, and I thought, well, how cool would that be if I could actually connect with their school back in their home country to do some science together and do some data sharing. Time zones may be an issue with that, but it's an idea anyway, something to think about.
Yeah, and I just have to say, Tom, this is one of my, when we first added the prediction tool feature in Logger Pro, that was a great improvement over the way we did this in workshop physics, which was to have the students sketch it on paper and then conduct the experiment and compare the two, and you'd look at one and you'd look at the other. But getting to overlay it allows for that questioning a little bit, like, does this match what your prediction was? And of course, we always have to tell the pre-med students that it wasn't necessary for them to erase their prediction and then write in the correct one afterwards, because they felt like they always had to have the correct answer. So this idea, though, that you have some free form, you can sketch, you can test out those ideas, and then you can immediately evaluate it. Just being able to layer those like this, I think it's a really nice tool in a classroom to get the kids to kind of think critically and just ask different questions, like, what if I tweak this parameter or that parameter? What do you think is going to happen? Just that idea of sketching a prediction and testing it out is kind of it's a good skill in its own, just to get the kids to start thinking about, make a guess about what's going to happen before you do it.
Yeah, absolutely. Gets them out of following the instructions so closely and actually engaging with the experiment.
Yeah.
Very good. Okay, so I'm going to move forward to the sample experiments. So I'm going to do a couple things here. I'm going to disconnect my force sensor. And then I'm also going to stop data sharing. I'll start another data sharing session a little bit later in the webinar, but for now, this is all stuff that what I'm gonna show you is things you can do with your session of Graphical Analysis Pro on your own without data sharing from me. So I'm gonna start a new experiment. I will not save my former experiment. And here are my data entry tools here. I can choose a saved file, but I'm gonna look at these sample experiments. So sample experiments are pretty cool. Let me go ahead and make this larger for a bit. So we've put in sample experiments from about 50 of our labs, chemistry, biology, middle school science, and physics. And we put this filter up here so that you don't have to scroll through all the other sciences and get right to the important ones here, down here at physics. And what we've done with these, I have to find the one I'm looking for here. It's the top of the list, probably. Cart on a ramp. It's my favorite one to demonstrate. Go ahead and load that experiment. So in this experiment, you get both a data set and a video. And that video is embedded into the experiment, so they open up together. You can run that video, you can watch Josh's hand come in and push the cart up the ramp and then carefully catch it before it runs into the end stop. But the real beauty of this is when you go ahead and go to this enable replay. Because what we've done is we've taken a video of this exact experiment so that we can synchronize the trip up the ramp and back with the video. And if I just press run here, you're going to see that video play again, but you're also going to see the data stream in automatically. So powerful, just a great thing. There's a couple of things that are worth mentioning here. First of all, I can hit play and I can pause it somewhere up here. Maybe I want to see when is the velocity actually 0? What's going on with the position at that point? I can inch forward and we see there's the cart is not going to get any higher on the ramp. I can let it go from there and it continues to run. I think so that's nice to be able to just kind of isolate particular circumstances in the video and with the data. But I think one of the really valuable things for physics teachers in particular is the ability to slow down this experiment. So many of our labs happen really quick. We don't really think about it too much, but you really can't see what's going on with any degree of detail. So you have the ability here to slow down the replay. And I'll just hit play again. And you'll see Josh takes a little bit more time to get into the picture. And then up he goes. And you can see the data coming in at a more leisurely rate. Really valuable tool to be able to explore this, this particular experiment or any experiment that things tend to happen fast. I joke that the biologists like to speed things up. So they're going 10 times the speed for these type of experiments, and we're trying to slow them down so we can capture those details. So this is, again, the sample experiments. There's a whole set of about 50 experiments that are just available. You can assign these as homework. So you could actually have students kind of flip your classroom around. You could have students do the lab at home, just looking at the video and performing the analysis that's required of the lab at home. And then when they come into your classroom the next day, you can unpack that lesson, and it could be a nice way to practice with that flipped classroom model. You can also use this where you don't have the equipment. Maybe you don't have a sensor cart like is demonstrated here, but you want to take advantage of that nice clean data. You can show this and have students engage with the lab with this this great data that maybe you don't have the sensors in your own classroom. Another great way to use this is for makeup labs. I can remember at certain times during the year having basically 4 different labs stacked up on my back counter, waiting for students to come in and make it up. And in this case, they really they don't get that hands-on quite so much, but they certainly get the gist of it. And it's probably a good option for both the teacher and the student looking at that as a potential. So it's nice to see that video embedded there. And that's the next thing I want to show you is how you can embed your own video with data that, of an experiment with data that you're collecting in your classroom. So let me just go ahead and start a new experiment once again. And I won't save that, but I will go ahead and choose a file. I have an experiment that I've taken a video of, and it's an impulse momentum experiment. So here's my data. You can't know this by looking at my data, but I had a cart on a level track, and that cart had a hoop spring on the front of it. and the hoop spring ran into the end stop, and that impulse caused a reversal in direction. So we have a position versus time graph and a force versus time graph. This is great in and of itself, but even more valuable when you hook up the video to it. So when you click on video on the graph options there, or view options, excuse me, and click on view or import video. I happen to have this set up in that same folder, and I'm just going to click on that and open it up. And there's my video. You'll see it's just 6.5 seconds long. We can watch it here. So there's me pushing the cart and bouncing off the end stop. Not too earth-shattering of a video. It didn't have to be a perfect video either, because I really just want to capture what is going on with the data. Now, somehow, you know, if we looked at, maybe I'll do that, I'll just replay this as it is now, and you'll see the data streaming in, and but the video is not synced with this at all. So we'll go ahead and close out of that. Actually, I will close out of that. So I want to pick a time in this video where I can say, oh yeah, that's what's going on here in the data. And I've decided to choose the point where the cart is moving on its own. So I'm going to go ahead and start the video. Oh, it didn't take long to get there, did it? I want to just capture maybe that point right there. My fingers just touching that, and you'll see that this is at 0.88 seconds in my video. And now if I come here to my position graph and click here, that's a pretty good spot, actually. There's this little ramp up where I'm accelerating the cart, but I think this is pretty much on that straight, that constant velocity section of that graph at 1.66 seconds. So remembering those two data points, actually, I don't have to remember them because I can still see them when I come up here. I'm going to come to this clapper, and I'm going to click on sync data with video. This becomes 1.66 for my data set time, and my video time is 0.88 seconds. And I'll just click on the clapper again, and we'll rewind everything, and we'll give that a play. Now I can slow this one down again. Maybe that's a good idea. And play it one more time. And you can see the data streaming in as that's collected. So a nice way to engage your students a little bit more with the whole idea of what is going on in this experiment. They not only have to collect the data, but they have to think about when things are happening and really investigate this. Certainly all the analysis tools are still here, so they can drag across that period of time and take a look at the integral to get that impulse value. And they can pick off the slopes before and after to get the change in velocities to analyze that impulse momentum theorem. Let me just take a breath for a second, since I've been talking for a bit, and see if there are any questions or comments that we need to address at this point before I move on to something else.
We had a question about supported video formats, and I'm looking through some of the help docs to see if I can find an exhaustive list of all the types that are supported. I thought HEIC is supported in this now, but that might require to switch to compatibility mode if you shoot it on iOS. I will keep digging on that.
Okay.
One of the things that we probably should mention here is that when you sync a video like this is kind of sometimes people will confuse what we're showing now, where we synchronize a video with an experiment, to a different app, which is the video analysis app, where you're actually clicking on an object in a frame to collect data directly from the position in the video. So that is a separate app than this one, which is meant more to be like an illustrative video of an experiment and being able to replay it and sync to sensor data.
Excellent point. Yeah, that is an easy point to be confused about, but this is all about syncing up a video of the experiment with data that you're collecting. Okay, and I shot this with just my iPhone. I do keep it on most compatible format for the quality of video. And it works fine, and it imports very easily as an MP4, or that's an MP4. At any rate, we'll go on to the next step here. So the next thing I'm going to talk about is the advanced curve fitting options in Graphical Analysis Pro. So once again, I'm going to start a new experiment. I'm going to save. And I'm going to choose another file that I've already created with a somewhat complicated curve or data form. So here we show that. I'll go ahead and stretch this out a little bit. And so we have here harmonic data, but it has a built-in decay function as well. So this is just fabricated data that I've created, but you can imagine an experiment that produces the same data. And if you go and look at your curve fit options by curve fit, you'll see a lot of options here. Quadratic, power inverse, inverse squared, natural exponent, sine, cosine, etc. But you don't see something that combines a sine or cosine wave with a decay factor. So we're going to just demonstrate how you can use a custom curve fit to help you with that. I'm going to start off by selecting cosine. And you can see overlays on top of my my data, a pretty good wave function there, but obviously not decaying as the function does. So I'm going to start with that as a starting point because it helps me build the custom curve fit. Custom curve fits, you can click on this right here, and it opens up this expression box here. This is the expression for the cosine equation that I've selected. I'm going to just back out a couple of things here. Before I get too carried away with this explanation, let me point out that we have here an x, which is always going to represent what's on your x-axis. That's your independent variable of the graph that you've set up. And the other parameters are just that. They're parameters that the curve fit tool is going to try to fit to give you the best fit for that particular function. And it'll do whatever you tell it to. If you choose a poor connection, it'll do its best to make it work. But obviously, we're going to try to make it better than just a sine wave function wrapped up around a decaying function. So I'm going to multiply that function by an exponential decay function. I'm going to put that negative d. So I'll come back to that here in just a second. Again, this is looking at Whoa. I think I'm being affected a little bit by the fact that I'm sharing this over the internet at the same time that I'm doing this, but let's just give this a minute to see if it kind of cleans up a little bit. It's working on it. So you can see that my exponential decay function has a parameter there, and it also has the what's on the x-axis right there. So you need to have that x value and then build in the appropriate amount of variables or parameters to fit that. If I just hit apply now, it's going to use this as the fit name, or I can name it myself if I want to at this point. So I'll just hit apply. And again, I think because I'm sharing over the internet while I'm doing this, it's taking a little bit of time to get there, but I'll just hold my breath for a moment. It's a good time to take a drink of water. And voila, there it is. So we have our curve fit overlaid on top of our data. Of course, my fit is pretty darn good because I had used fabricated data. But you can see that my A parameter is -5, which is interesting. So it gives me a phase change angle of pi. So it's basically taking that. It could also just have returned my C parameter is 0, and this is +5. And then it gives me this decay factor of 0.2 there, as well as the root mean square error analysis. Now, let's see. I had intended to data share that, Jake, but I got all the way through it without data sharing. So I apologize to you out there in webinar world, but this next thing I will share with you, I'm going to demonstrate collecting some sound data and performing an FFT.
So Tom, before you switch gears, we did have a couple questions on chat, if you don't mind.
Not at all.
So one was, is it possible to plot and fit 2 or more different curves with the same X values on one graph?
2 or more different curves. So if I had another data set presented on this graph, is that how you're interpreting that question?
2 or more different curves with the same X values. So I'm assuming that it's the same data, but having like fit it both with a sine wave and with a cosine wave. That's how I read that question.
Yeah. At the risk of seizing up my version of graphical analysis, let me just apply another curve fit that maybe is inverse. Well, I'm asking for trouble, Jake, but the answer is yes, you could apply 2 curve fits there, and it would give you if I hold my breath, will that work again? And now that I've said that out loud and tried to do it, Jake, I'm wondering if what I said was true. So we may need to follow up with that.
All right.
Maybe you can test that on your device that's not sharing over.
Yeah, it could be that mine's going to be able to do it faster. And then another question, is there a facility to have the students choose the parameter values rather than the software picking the values?
Well, you could force those parameters. You have to have at least one parameter for a curve fit to apply a curve fit. So, but you could, for example, force the values of pi if you wanted to. You could, for example, in this example, you would have to have one of these parameters available for the curve fit tool to work, but you could enter the values for the others just manually. Just enter numbers in the curve fit setup instead of the A, B, C, and D.
Right.
Okay, I'm guessing that my example is not going to work, and for having two curve fits on the same graph. But let me go ahead and move forward if I can. Okay, so I'm gonna start a new experiment. Once again, not saving that one. And actually, I'm going to close graphical analysis altogether because I think I've been asking it to do a lot, and I want to get a fresh start here. So start it up again. Drag it back into the screen here. And in this case, I am going to, let me increase the font size again. So I would like to do that so you can see it better. And at the risk of totally embarrassing myself, I'm going to sing into my sound sensor to get some data for this. But let me go ahead and start a data sharing session again so you can share in the exploration of the FFTs. Let me copy that to the chat. This time I will send it to everyone. And I'll blow it up here so you can see it as well. That's CEK8SA is the code for this data sharing session. And I'm going to go ahead and connect my sound sensor. And looking for that sound sensor. I'll just point out that there's a variety of ways you can connect to the sensors. One of the things I really like to do is to use this filter. And what I do is look at the serial number on the sensor, ends in C2. So I just come up here, type in those last two digits, and it just zeroes in on the sensor that I want to connect to, allows me to connect to it. And then I can click done.
But if you haven't used Proximity Connect and you have a sensor handy, you should try that one because it's pretty cool.
It is cool. Yeah, it's a little dangerous here at Vernier headquarters where there are
sometimes
sensors.
We have in fact filed bug reports where we're like, well, it breaks when I do this, and then it's like, well, why? Oh, it's because you had 200 go direct sensors all on right there. You can easily have one classroom's worth, but you can't really have 20 classrooms worth without that list getting a little bit unwieldy.
Okay, so now I'm connected to my sensor. I'm going to sing an E, hopefully, and will an E, not an E note, but the sound of E, and hopefully we'll get a decent sine wave out of this. Well, that's not bad. It's not a sine wave, but I never promised one. So there we go. So the nice thing about this is it does show a waveform. When I was teaching, I used to have my students bring in their musical instruments in the spring so that they could all look at their waveforms. My favorite story about that is somebody who could sound like a trumpet, but actually didn't own a trumpet. And their waveform was exactly like a trumpet. So it's pretty cool. To show the FFT, I just come again to my graph options and choose apply FFT. And here you have the opportunity to see, okay, my peak frequency is kind of in this neighborhood. So I could click there and get that value of 332 hertz. You can look at the overtones that you generate with that and talk about how that that relates, in fact, to the shape that you're seeing here in this waveform. So a great way to just kind of toggle back and forth between general size of that frequency response and then the waveform itself. Again, another nice feature built into Graphical Analysis Pro that you're going to be looking for when you're investigating sound and waves. Jake, that is actually all that I had prepared for this webinar. Are there any other questions out there that we should discuss, answer?
I'm typing an answer one right now, but it's probably faster for me to just say it out loud. So there's a question about what other DACs that graphical analysis works with. So it works with I was going to say all, but there's always an exception because we've been at this for 40 years. So it won't work with our, for example, our Palm-based interfaces or some of the other earlier things. But basically everything we've made since about like 2010, 2014, something like that. So the whole LabQuest family, GoLink, all the GoDirect sensors, et cetera, all those will work with Graphical Analysis Pro.
I see there's a question about another app to analyze video. So if you're interested in collecting, taking a video and analyzing the motion that's represented in that video, that app is called Vernier Video Analysis. Another great tool. A lot of resources on our website for checking that out and learning how to use it as well.
Yeah, and that one is, as we see a lot of people switching, moving to Chromebooks, where Mac and Windows-based apps won't run, then you need to use graphical analysis, and video analysis is one of the things that was built into Logger Pro. But because Logger Pro got to be this giant Swiss Army knife of everything, we found that the video analysis features really work better in their own app, and that's the Vernier Video Analysis. So I'm putting the link to that. Oh, Dylan was one ahead of me there. So that's the Vernier Video Analysis app, and that one runs entirely in the browser, and that's what will let you take the data from clicking on the points in a video. And we also have a few books of labs that use that for that style, which is really fun because the students will usually make their own videos with their phones, and then you can kind of meet them at their interest level. If someone's into soccer, you can have them make videos of soccer and then analyze the physics of it. Question about how GA is different than Logger Pro. I can look up the document for that. There's a long list of sort of like, it's the core of it is that they basically do the same core function. You can take a sensor, you can get a real-time data graph on it. That's the single best thing that any of them do, is being able to see the real-time data come in from the sensor while you're doing the lab, and then you can do all sorts of analysis in it. Now there's some little things. We spent a decade, maybe 15 years, adding basically every feature that physics teachers asked us to add to Logger Pro, and we've added almost all of those to Graphical Analysis Pro now. There are a couple, so they're all. I can never say all because there are always some funky little corners, but we have an exhaustive list there, and I'll post the link there. That basically Graphical Analysis Pro is kind of the software to use going forward, because it's going to run on not just Mac and Windows, but also Chromebooks and phones and tablets and kind of all the devices that are in use today.
I see Lynette has posted a question about the difference between the free version and the pro version. And there again, there's an article on our website that addresses that. And I think unless Jake is really quick and can drop that into chat as well, I'll definitely follow up and provide that information to you as well. I'm recognizing that we're a little over time. I want to respect your commitment of 45 minutes in the middle of summer. And with that, I'll Oh, Jake got it in there, free versus pro, very good. So feel free to, if we miss questions in chat, we'll scour over that and provide you some answers in the next day or so. Thanks very much.
Thanks, everyone. Have a great rest of your day.